Hello and welcome back. In this video we'll be looking at section 2.8, which is all about distance and circles. So to begin with, let's remind ourselves of the Pythagorean Theorem, which says that for a right triangle, if the side lengths of the triangle are A and B for the two sides next to the right angle, and C for the side that's opposite of the right angle, then the distances A, B, and C are related in the following way: A squared plus B squared is equal to C squared. And remember that C here is the long side that's opposite the right angle. A and B, it doesn't matter if I call A and B like this, or if A and B are like this. It doesn't matter which one is which. So this is the Pythagorean Theorem. And this is what we'll use to come up with a formula for the distance between 2 points. So when I want to find the distance between 2 points, say x1, y1 and x2, y2, what I want is the distance of this line here. But we can start to see a triangle pop out if we do the following. If I draw straight over and then straight up, now all I need to do in order to find the length of the long side across from the right angle, all I need to do is know the distance of this side and the distance of this side. And this is fairly straightforward. Here, if we're going from x1 over to x2, this distance here is going to be x2 minus x1, the difference in the x values. And over here, the distance from top to bottom, from y1 to y2, is going to be y2 minus y1. So the length of this side, if I call this length d for distance, then I know that the following is going to be true. If I take this side and square it, plus this side and square it, it will be equal to d squared. And that gives me the formula. If I solve for d, I just take the square root of both sides, and d will be the square root of x2 minus x1 squared plus y2 minus y1 squared. Note that if you were to actually solve this for d, I could have this or negative this. We always have a negative solution when we're dealing with square roots, but we can't have a negative distance, so I get to ignore the second solution. So this is our formula. So let's apply that. Let's find the distance between -1, -3, and 2, 3. So we'll come back to this formula in a second. I have a picture here. So we want to find the distance from -1, -3, and 2, 3. So it's the length of this line, approximately. So I need to go from here to here. So if I wanted to, I could draw a triangle, and I'm looking for the length of this side. So all I need to know is the length of the other two sides, and we're good to go. Luckily, I have my formula. So d is going to be the square root of x2 minus x1. So this is the distance in the x direction, plus y2 minus y1 squared. And y2 minus y1 is the distance of this side. So if I call this point x1, y1, and I call this point x2, y2, we have the following. This is going to be 2 minus a -1 squared plus 3 minus a -3 squared, and we're taking the square root of the whole thing. So 2 minus a -1, that's going to be 3, so that's 3 squared. 3 minus -3, that's 6. We are adding these, and we're taking the square root. this is going to be the square root of 9 plus, and then 6 squared is 36. This is going to be the square root of 45. So this is the distance from this side, from this point up to this point. Now I could simplify this a little bit, since 45 is going to be 3 times 3 times 5. This is going to be 3 root 5, if we wanted to simplify that radical. So we can also find the midpoint between 2 points. And when we draw a line between 2 points, the midpoint is going to be the point exactly halfway between. So it'll be, I don't know, somewhere around right there in this case. So when we have the midpoint, it would be nice to have a formula for it. And it turns out that we do. The midpoint between 2 points, the way to read this is the average of the x values, and this is going to be the average of the y values. So to find the average of two numbers, you add them together and divide by 2. The average of 2 numbers, you add them together and divide by 2. So x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So again, let's just go through a quick example. To find the midpoint of the line segment from 1, 2 to 7, negative 3, the midpoint will be, I don't know, about there. So what we want to do is we want to use our formula. So the x value, so let's find the x value for the midpoint. It's going to be the average of our 2 x values. So 1 plus 7 divided by 2, which is simplifies to 8 divided by 2, which will be 4. And then the average of the y values will be 2 plus negative 3 divided by 2. So that's going to be negative 1 over 2. And if I write that like this, so the midpoint is just 4 negative 1/2, which is about right there. So far, it's pretty good. We have a formula for the distance between 2 points, which uses the Pythagorean Theorem, but and we can always draw a triangle to figure this out, but it'll be the difference in the x values squared plus the difference in the y values squared. Take the square root of the whole thing. The midpoint is just going to be the average of the x values and the average of the y values. And what we'll do is we'll put all this together and we'll come up with a formula for a circle. So a circle, okay, so most people will understand this, but we'll just define this in the technical sense. It's going to be a set of points that are equidistant, so they're all the same distance from the center. And then the distance from the center to the circle itself is called the radius. So if you can tell me where the center of a circle is, and then if you can tell me what the radius is, we can define a circle. That's not a very good circle, but we'll live with it. So here, if we have the center, if you look at the distance from the center to the outside in any direction, so let me put this in a different color. So if you look at the distance from the center of the circle to the outside in any direction, it will always be the same length. My drawing isn't exactly perfect, but we can get the picture. So what this means is that if the center of the circle is called HK, I didn't come up with this notation. This is, but this is common notation in lots of textbooks. The center to be called HK. If we pick any point on the outside, let's call this just XY. So a point on the circle, we'll just call XY. The distance between these 2 points has to be exactly equal to the radius. So let's call the radius R. And then we get the following. The distance from the center of the circle to the outside has to be equal to r. So r is going to be equal to, we have the difference in the x values squared plus the difference in the y values squared, and when we take the square root of the whole thing. So the distance from the center of the circle to the outside is given by this formula. However, what we can do with this is, since we have a square root on this side, we can square both sides to make it a lot simpler. So here, if we have r is equal to the square root of this big mess, what I can just say is if I square both sides, I'll just have that big mess is equal to r squared. So this is our equation for a circle. It may look a little complicated, but there are only 3 things that you need to know. In fact, let me amend that. There's only 2 things you need to know. We need to know what the center of the circle is, we need to know where the center is, and we need to know the radius of the circle. Once you know that, we know the circle. Just like up here, once we knew what the center of the circle and how far away it is, we could then draw the circle. So all we need to do is know the center and the radius. So let's write down a couple of examples here. So let's give the standard form of the equation for a circle with center 0, 0, and radius 4. By the way, this is called the standard form of a circle. We'll see one other equation that gives a circle as well. So we can imagine that we've got our coordinates, our center at 0, 0, and let's say a radius of 4. So that means our circle will be centered there. And again, so this will pass through -4, 4, -4. It has the same radius all the way around. So it should pass through all these points. And let's use our equation up here. So we have x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared should be equal to the radius squared. And now I can simplify this. X minus 0, well, that's just x. So x minus 0 is x squared. Y minus 0, well, that's just y squared. And then lastly, 4 squared is 16. Now, if we were to simplify everything, I would write down 16. Sometimes it's helpful, though, to write down 4 squared because we know that this is going to be the radius squared. So it's sometimes helpful to leave it as 4 squared, although this is as simple as we can make it. Let's do one more example. And again, here we've got our coordinate system. We'll go to 1, -6, and we'll make these quite small. And then the radius of 10. So the radius, if I go straight up, it will cross about here. If I can make a circle, or maybe that's more of an egg shape, but we'll pretend it looks like a circle. So again, the formula for this is quite straightforward. We have x minus the x coordinate of the center squared plus y minus the y coordinate. So we're going to get this double negative in here. Squared is equal to our radius squared. So again, simplifying, I can't simplify x minus 1 squared. That's already nice and factored. Here I have y minus a -6. Well, that's the same thing as y plus 6 squared. And 100 squared, 10 squared is 100. So writing down the standard form of the equation for a circle is pretty easy. You only need to know the center and the radius, and you just plug it in.